experimental probability. So experimental probability is based on repeated trials of a probability experiment. So theoretical probability, let's go back to our example of rolling a die. Okay, in theory, the probability that I roll a 2 is 1 out of 6. The probability that I roll a 3 is 1 out of 6. The probability that I roll a 5 is 1 out of 6. But what happens if I actually sit there and roll that die repeatedly? Do we really think that I'm going to get a 5 exactly 1/6 of the time? It may happen, it may not, and that's where experimental probability comes in, which is, well, what actually happens when I run the experiment? Example 5. Each section of the spinner shown has the same area. The spinner was spun 20 times, and the table shows the results. Part A. For which color is the experimental probability of stopping on the color the same as the theoretical probability? Well, let's start with the theoretical probability. In theory, if I'm looking at this spinner, it looks to me like I've got 1/4 chance of stopping on blue, 1/4 chance of stopping on yellow, 1/4 of stopping on red, and 1/4 of stopping on green. So that's my theoretical probability. Now, if I look at the results from the table, and we know that we spun it 20 times, well, red, I spun 5 out of 20. Green, I spun 9 out of 20. Blue, we spun 3 out of 20. And yellow, we spun 3 out of 20. And they're asking, well, which color is the experimental probability the same as the theoretical probability? So I'm going to look at this 5/20ths here. And if you simplify this, you're actually going to get 1/4. So the answer would be red, because they're both 1/4. Part B. For which color is the experimental probability of stopping on the color greater than the theoretical probability? Well, we know that red is the same, so now I'm looking at green. So the theoretical probability of green is 1/4, but the experimental probability is 9 out of 20. And I know that 9 out of 20 is greater than 1/4, so that would be green.